Good morning, good afternoon, depending on where you are, and welcome to this webinar on the topic of why you need DataOps in your organization. My name is Kwok, and I'll be your host today. I'm joined by Unravel's co-founder and CEO, Kunal Agarwal, who will be sharing the reasons why your organization needs DataOps. Hello, Kunal, how are you?
Very good, Kwok. Thank you so much.
No problem. Before we start, here are some quick housekeeping rules. So if you do have any questions, feel free to pop them in the questions box below, type in your question, and we'll answer them live at the end of the session or by email reply. Just a reminder, this webinar is available instantly on demand. So if you do have to drop off, feel free to come back via the same link and watch at your leisure. Let us know what you think about this session by rating this webinar and letting us know on other topics you'd like to hear about, and let us know if this really struck a chord with you guys. I do believe we have a few questions around going on full screen and removing the banner from the page. If you just want to go full screen on the player, then you're able to kind of watch in full screen mode. Right. So without further ado, I'm going to hand over to Kunal, who will then start the session. Thank you, guys.
Awesome. Thank you, Kwok. Hey, guys, welcome to a talk about DataOps. It's a topic that a lot of you data practitioners are probably thinking about today and already probably have some form of it implemented inside your organization. Before we get started, let's actually do that as a quick poll. Let me know if you see this poll over here. It'd be good to understand how many of you in your organizations or companies actually have a data ops practice established today. You could answer yes, you could say no. Even if it's partial or a maybe, you can take that third option. May take a couple of seconds here to give you guys some chance to vote over here. And then towards the end of the webinar, we'll actually share these results with all of you. Please, if you guys see a button there, let's get your votes in. Take another 20 seconds or so.
All right. Come in.
There are a lot of answers coming in. Keep them coming, guys. Going to keep this open for another 5 seconds or so. Just trying to get all the data that we can so we can share it back with you.
Yeah, fantastic. Just a quick mention as well. We've got a couple of resources in the attachments section of the webinar. So if you go below the player, you're able to click on attachments. We've got a link to the Eckerson DataOps deep dive, which will give you a really fantastic overview and analysis of the current landscape. So definitely download that in the attachment section. And also for those who are intrigued about what we do after this session, feel free to sign up for a 14-day free trial. We're also giving away free Data Lover t-shirts as well, and we'll send more email about that on after you guys have watched that.
Awesome.
Right.
So I'm going to be ending the poll now. Thank you so much for all those responses, Kwok. Can we pull up the results?
Yes. So let's take a look at this poll. Right. So for those that are watching, you can now see the results of the poll. Do you currently have a DataOps practice established in your organization? 18% of the respondents say yes. 43% say, 44% now, it's changed slightly, have said no, and 33 have said partially, so somewhat. Is this something that you're seeing right now in the industry, Kunal?
Absolutely. DataOps is a new practice, and while everybody is trying to establish it, I think one of the biggest reasons people don't have it established is they don't have a set of common guidelines or practices within all of the different data team members inside the company. And that's what a lot of today's talk is going to be about. So continue to post your questions as you're going through this. We want this to be as interactive as possible. I am going to share my screen here. Hopefully you guys can see this. And today's talk is all about how do you simplify data operations, right? And we're going to be giving you some very practical, tactical advice and steps that you guys can take in your organization as well to radically simplify data operations. What's common between Spotify, this text that you see here, probably you guys get a text like this on your phone every now and then, and your favorite ride-hailing company? All of these apps here and many, many more are powered by data, machine learning, and AI. And every company today, as we see, is transforming into a data company. While every company used to be focusing on creating software, now every company is trying to get ahead with doing a lot of these data analytics. And there's a lot of different use cases, from recommendation engines to fraud prevention to going and understanding, just the customer very, very well. And your company may be doing one or many more of these different data products or data pipelines. Now, for all your data practitioners out here, you know this very well, that data pipelines are very, very, very complex, right? It's got a lot of different stages from if you start from left to right. A lot of different data producers, things that you're gathering the information about, that comes into a streaming or a ingestion engine, probably using Kafka for that, Kinesis if you're on AWS and so forth. And a bunch of different data integration tools are then used to put all of these different data pieces together, which may then be going into a data lake or a data warehouse. And from there on, you're doing a lot of different things with data, from creating dashboards and business intelligence reports to doing machine learning and AI on top of that data analytics. And a lot of these companies are actually creating a B2B data exchange as well, so your partners and vendors can access this data as well. Guys, I guarantee that your data pipeline looks much more complex than the simple picture that we've put together over here. And there's a lot of moving parts out here, which means there's a lot of things that can go wrong over here. And there's a lot of different people in your data team that may be responsible for different pieces of this pipeline. Not to mention, there's a lot of different technologies that you may have to put together to create these kind of data pipelines inside your organization. Without DataOps, these data pipelines are always error prone and always broken. You're not going to be getting the results. You're not going to be getting the reliability. You won't get that synchronization between all of these different team members that you have on your data teams if you don't have a set of well-established practices that have to be followed between all of the different players inside your data team itself. This leads to often poor performance, right? We've seen this a lot of times, that if you have applications that are customer facing, your customers are complaining about these data pipelines not working. You may have your machine learning model that it's not updating on time. Even your internal reports could be something as simple as bringing the data in or providing a business user that dashboard, not showing up on time. And there are some service level agreements or SLAs that you may have with your internal or external customers, which obviously leads to a lot of frustration if things are not happening on time. Without a data ops practice, you're always going to incur a high operational cost. Whatever your budget is, you always see yourself overshooting those budget boundaries. And this is both in running this entire data pipeline and even on the support side, maintaining and managing and making sure that these data pipelines work on time every time. And not the least, but you're also having a finger pointing culture inside your organization, right? Where you have the data teams and the operations team saying, it's not my problem, and go and talk to somebody else, or I've done my part and I don't know what to go and do in your part. So there's just a lack of collaboration and people, moving forward together in their data vision. So what is data ops? There's a lot of different definitions out there, but ultimately, data op refers firstly to the culture and secondly to the rules of engagement that allow your entire data team to deliver high quality, on-time data products in an agile and cost-effective way. It's about putting these players together in your data ops team so that they can operate like a well-oiled machine. Now, you may have one or many of these roles inside your data teams as well, starting off with the data architect. He or she is the person that's putting this entire data pipeline or even the data infrastructure together. Where should we run this? Should this be on-premise? Should this be on the cloud? Should this be on AWS? Should we be using Spark? Should we be using Kafka? This team of people design based on the business needs that your company has around data. Then you've got the data engineers who take business requirements, usually from a line of business, maybe from marketing, maybe from finance, maybe from product, and actually put the plumbing pieces together. They may be writing the code in Python or Scala or R and publishing it so that the team can start using those data products. You also have the data scientists who work very, very close with these data engineers. They're usually the scientists. They're the modelers. They know R. They live in Python. These guys also understand the context in which your industry is working. So they've got a lot of subject matter expertise, and they're able to find the needle in the haystack as they're sifting through all of this different data using the different techniques. They may be working very closely with the data engineers to finally go and publish their application in production, while they are the people who are modeling all of these different models and algorithms. Then you have the data analysts. Just like the data engineers, these guys focus primarily on reports, dashboards for the businesses, and primarily live in SQL. Alongside them, you've got the data operations folks. This team member is becoming more and more important in this entire data ops value chain, because they are the ones who are usually making sure that everything is working properly. Now, in your organization, you may have data engineers and data scientists and the analysts, the end users themselves, be responsible for maintaining their own set of data pipelines and applications. In that way, the data operations becomes a helping hand who is usually an expert in all of these different data technologies that you may have inside your company. So if you ever need to peek under the hood, your Scala application is not running properly, you can go to the data operations person who may know the Spark and the Kafka and the MPP engines in a much better way, so that they are able to go and figure out what's actually happening and how do you get things back on track. They usually also respond and are managed by the data leaders, because they have a responsibility to also make sure that your entire data real estate is running like a well-oiled machine and it's cost effective. And there's a new role called the Chief Data Officer that may be presiding over all of these things, whose mandate in the company dictates where a company is going down in their data journey. This may also be the Chief Information Officer, or could simply be a product owner as well, who's in charge of providing the budget and the direction for all of these different data endeavors inside your company. Now, I'm going to take a quick poll here from you guys. Kwok, if you can get the second poll up. Do you currently have a data ops title inside your organization? So just the role title, or somebody that does that operations piece. We're seeing more and more on LinkedIn this role come up. And it means a lot of different things to different people. It could be the person that is doing more of the architecture. This could be a person that is doing more of the troubleshooting, or could be a person that's doing more of the forecasting and scaling up of the environment as well, as the needs of the organizations keep changing. So this poll question is up. Please take some time. We're going to keep this open for another couple of seconds over here to understand, do you have a data ops role title inside your organization today? Maybe another 10 seconds. Please get those answers in. 5, 4, 3, 2, 1. And let's end poll. What were the results?
Right. So as we're gathering the results of everyone, of all the 40 people who took part in the polls, do you currently have a DataOps role title in your organization? 8% say yes, and an overwhelming 91% say no. Wow. Is that something that's quite? Do you see this often, Kunal, in the field, or is this astonishing?
It's not really astonishing because the title name itself is new, but you may already have people inside your organization that are responsible for the duties that a data ops person usually has. Let me continue sharing my screen here. So a data ops role is central to making sure that whatever we're going to be talking about today in terms of the best practices are followed. They are the ones who are brokering the conversations between the end users, the system admins, and the management. So it's an emerging role. So we're not surprised that a lot of companies don't have that role just yet. So today, let's take a simplified view of data ops. I'm sure all of you have been reading reports and information about what is data ops, how do you get data ops into your organization. We're going to be taking a rather practical view and understanding what are the different stages of data operations and what are the different stages of your pipeline development lifecycle. You used to have the SDLC in the software development lifecycle. And what are some of the things that you could be taking away from today's talk that you can go and implement right away in your organization to improve the data ops outcomes inside your company? So it starts off on the left side with planning and then goes to coding, which is pipeline as a code. And in data world, you have both the code, the text itself in Scala or Python or R, but you also have to worry about the data itself. What data sets are you using? What should the partitioning of the data sets be? It's very, very important as these are large scale data systems that you get that right as well. Otherwise, you're just going to have very poor performance or even worse, not the right results. Then we'll talk a little bit about testing, what you should test, what is usually missed out in testing, and how you can make sure that testing is done appropriately so that when you do have your integration and deployment, that you're not deploying poor code and poor pipelines in production. That's a key part about deploying, which is how do you ensure that you have some sort of a health score or a gate so that all the people that are creating these applications are able to see good benefits on the production side. You may also have 3 different environments, a dev cluster, a QA cluster, and a production cluster. Deployment that happens obviously from what you need to do from dev to QA to prod, and how do you actually deploy it across those different environments as well. Then we will move into the ops part of data ops, which is operate, monitor, and continuous optimization. We'll take a peek into how you should be operating, what are some best practices for monitoring, and what does continuous optimization really mean? Always remember that data ops is not going to happen successfully unless you have end-to-end observability and real-time collaboration between all of those different people that you saw in the previous slide in your data team. So guys, let's jump right into it. Planning. What does planning mean for a data pipeline? When you're creating a data pipeline, the architect may have given you certain tools and technologies to work with within your organization, but it's always important to select the right tech and the right environment for your app. You should always understand what your app wants to accomplish. Do you want low latency? Do you want a model that works on a high intensive data set? Do you need something that's streaming, something that's real time, something that's batch? Do you want to run this on premise? Do you want to run this on the cloud? Do you have data requirements and processing requirements that need a bursty architecture? Maybe you're running some application that's good for the holidays, And during the holiday season, you may be anticipating a high growth in the volume of data that's coming in. A lot of different factors go into planning. And if you get this step correct, a lot of the following steps in your data ops practice will just fall into place automatically. So selecting the right tech is very important. All of you may know that there's just so many different pieces of technologies to go out and work with. It could be Spark, Hive, Hadoop, Redshift, Impala, Presto, Drill. What do you go and choose should all matter. It should start from what do you want to achieve with your data application itself. And once you've selected that right tech and environment, you should be able to right size what your requirement for the infrastructure in terms of CPU, memory, IO, etc., will be based on performance and your cost needs. This pretty much happens in inverse in a lot of organizations that are not following data ops practices, in which they will just size their containers to be the biggest size. And if everybody in the organization is doing that, then you run out of resources and capacity that your architect designed very, very quickly. So it's important that you profile and understand your data pipeline and then map it to the different available architectures and tools and technologies that you may have inside your organization. Now, we've taken the liberty to show you some of these different steps using our technology, which is Unravel. But you can do this if you have this kind of information about your application and map it and understand what the cost and what the requirement based on the kind of performance and cost needs that you currently have. So on this screen here, we've taken a slice of an application that we want to run on a technology called Amazon EMR, which is a big data bundle, if you may, that Amazon provides. And in this case, you can see here that to run this particular pipeline, I would need certain amount of storage, certain amount of memory, certain amount of CPU in the form of cores. And it's actually been able to take that profile and map it to how should I be running this on EMR? And it's giving me the topology for that. So in this case, it's recommending that for this particular application type, I should go and get these type of machines, about 14 of them. And this is going to be the cost of running this type of a pipeline or application on Amazon EMR. I'm also taking some performance and reliability needs here. I've said this is an important pipeline that needs to run on time every time. And for that, I'm going to be incurring a $104 cost versus if this pipeline was not that mission critical and it could be a little slow on certain days, I could go for a $94 option with an 80% SLA guaranteed on that. There's a lot of other different things out here, like how would this pan out if I needed bursting, if I needed to scale up? And that's when you can do some math based on the profile of your application to go figure out how does this map to an auto scaling or a bursty cluster on Amazon in this case, but it could be Azure or GCP or Databricks that you guys may be running in your environment. It's a very important first step. People usually forget to do this and just run away with their code. So take some time to sit down with your architect, figure out, hey, can you help me understand this is what I want to run? This is the data set that I currently have. How will I profile this application to make sure that I can plan correctly for it? Now, coding. This is not a talk in which we'll give you coding best practices. That's outside the scope of this particular conversation. But one important point that a lot of people forget is it is a data pipeline. And while you may be writing one piece of the code for the pipeline, it's important to understand the behavior and the data flow of that pipeline end to end. You may have a pipeline that starts off in Kafka through some topics, bringing in some data into, say, HDFS, where you may be doing some joining of tables, for example, and creating a Hive table, for example. You may be then using Impala or Presto for doing some scans on that particular table, and then you may be doing some data analytics using Spark. If you're responsible for the entire pipeline, it's great that you can see that pipeline end to end. If you're not, again, using some sort of an observability platform, you should be able to stitch those different stages up so that you can go and understand the behavior of this end to end. Because the business requirements doesn't care about one stage. The business requirements cares about this entire pipeline finishing within 2 hours or by 8 a.m. in the morning, every morning, for example. Because then it's important to go and understand, hey, where in this pipeline am I spending the most amount of time? Which of these stages in this pipeline is doing the most data processing? Which one of these stages can be tuned or remove the bottlenecks from in this entire stages so my entire pipeline works in a very reliable fashion as well. So this screen here shows you one such simple pipeline, which has about 4 stages. I'm sure your pipeline's got hundreds of different stages. That's a real world pipeline over there. But very quickly, you can glance the 4 different stages, and you can point out very quickly that stage number 1 is taking a lot of time. And then in this case, it's Unravel's tools also points out inefficiencies, and it's telling you where the bottlenecks are, which this stage of pipeline is taking about 57% of the total duration. And that's where I would be spending time to go and get the total duration, for example, while I'm coding itself down to the bare minimum that I can. Because when I'm coding, I may be running this against a sample data set. And when we put this in production, we may be running it for the whole data set. So you want to make sure that things are efficient from the get-go. This is a very important point that a lot of people miss because they're so focused on just their portion of the pipeline. Testing. I'm sure all of you have got your own testing matrices. All of you have your own golden rules for testing inside your organizations, right? So some of these are the obvious ones. You've got to check for failed and error stages. Again, comes with the entire pipeline in place, right? You've got to make sure that are there any warnings or errors within each of these different stages? And what can you do to make sure that those stages are running properly? If you're able to view the entire pipeline end to end, work with the people alongside you in your team, in your data team, that may be doing ingestion, for example, versus people who may be creating the dashboard, and work very closely with them to make sure that all of these different pieces are humming properly. You want to also verify for correctness, right? Correctness is not just the business team's problem. You have to make sure that if you are the data engineer or the data scientist, that your application is giving you the correct results. Performance is great, everything is running properly, but if you're not getting good results, if you're getting bad output, if that's a data quality issue, or if that is a join that you did wrong, now is the time to go and check for those pieces as well. So we highly recommend writing tests for both efficiency, performance, but also for correctness and quality. And last but not the least, the resource efficiency part is a big one. Now, this is the last step before your application is put in production. And you want to make sure that whatever you planned out for your application in the form of CPU, memory, etc., that your application is using those resources efficiently. Too often we see companies are running these applications in a multi-tenant environment. You're not the only user that's perhaps submitting jobs in your Databricks environment or your Azure HDI environment or your Google Data Proc environment, for example. There are dozens, if not hundreds of other users that may be running data pipelines on that same environment. So you want to be a good citizen. You want to make sure that you are only utilizing the resources that you are allocated, and you're not abusing or wasting those resources over here as well. So you should write tests to make sure that your applications are resource efficient. Deploying. This is a fun one. This is where the handshake between the developers and the hands on the keyboard and the people who are creating the applications and the operations platform and system admins happen, right? And this is where a lot of, today, a lot of problems just get thrown over the wall and says, here, you guys take care of it now, not my problem anymore. In a good DataOps environment, everybody takes equal responsibility to make sure that things are running in a healthy fashion in production as well. And if you are able to do this step correctly, then as data engineers and data scientists, you're not going to be woken up in the middle of the night if something is amiss. So why don't we do a health check before promoting the application to production? Now, this is taking the liberty here to show you an Unravel screen, for example. If you bring your attention to the top part, it says inefficient applications. Now, if there is a way for your company to scan the applications, this could be done by your data engineers themselves. Go and test that the application that you're asking for promotion, that the application that you're trying to put, especially in a production cluster, has some standard checks to ensure that it is of good quality. In Unravel, we can hunt for those automatically and pop up and say, hey, these are all the applications that you have in your cluster that you need to look at to make them efficient. Because it hairballs into a big problem that you've got 10, 15, 20, 30% of these applications that are making to production that are not efficient. And the efficiency could mean a couple of things. It could be very slow, or it could be very expensive. And you want to make sure that those things are caught before you're running it against these large data sets in production. The second part about deploying that people usually forget is, again, especially if you've got a multi-tenant environment, when should I deploy my pipeline? You want to have a good view, something similar like this. What you're seeing here is the days of the week and the different hours in the day. It's a simple heat map showing you what's the capacity of my environment, what's being used at that particular point. If you do this over 2 or 3 different weeks, you'll start to see a pattern emerge around when your cluster is used the most and when your cluster is not used. So if you have certain SLAs that you need to meet, ask that from your business team, ask that from your data architect as well, and understand, hey, this pipeline, because I've measured, because I've optimized it, takes 2 hours to run. And I want to make sure that I get the results by 8 a.m. in the morning. Then guess what? I can look at a heat map like this and say, Monday morning, 4 a.m., 5 a.m., 6 a.m., 7 a.m., 8 a.m. look green. They're nice and open, environments at that time. Not a whole lot going on at that particular point. So maybe I should schedule it at 5 a.m. on Monday. If you drop this pipeline on a Saturday, for example, at 4 a.m., it's not going to finish on time because Saturday is a very, very heavy use time in the mornings. This is probably when a lot of our weekend jobs are running as well. It's a pretty common use case, but just having a simple graph like this will go a long way in making sure that, number one, your pipelines are finishing on time, and number two, you're not stepping on your friends' pipelines and making sure that those pipelines finish on time as well. You guys have all this cluster capacity. Just a simple graph like this will make sure that you use it in a more efficient manner as well. Now, you've got your pipeline in production. Well, you've got to go operate it. Now, one of the key things people forget out here is that you are in a live environment. And a live environment may mean that your data sizes are changing every day. You may be running that same pipeline every day, but today you're processing 2 times more data. You may be running that pipeline in an environment where 3 users or 10 users or 100 other users are running, and they may start stealing resources from you. You could have an error in one of the stages in your pipeline. So you want to be able to detect and fix that deviation that you have in your performance in a proactive manner. On a screen like this, what are you looking at? This is the name of my pipeline. I've got a pipeline called crime types. And my crime types pipeline has run 135 times. And it's showing me a visual representation of duration and IO and resources that are available for this particular pipeline. As you can see, the first 100 runs were pretty okay. And then after that, I see a big spike in showing me that how slow this particular pipeline has become. And then I was able to fix it and get it back to running on a normal time again. Now, you want to be able to get these kind of alerts and understanding proactively. We'll cover that in the next section of Monitor. But you want to be able to make sure that not only are you monitoring your pipelines, there is an operator that's looking at the entire environment as a whole, because you want to eliminate rogue usage on a shared cluster as well. What does rogue usage mean? It's one of those users, and I know we all have one in our company, that does a select star, or does a join on a very expensive table, or doesn't check for efficiency in pre-prod, and writes an application like a cowboy on production environment, and then starts to take up a lot of resources on this environment. And then all of my mission critical pipelines like this start to suffer. So you want to work very closely with your operations team to help you create a dashboard, maybe just for your pipelines, while the operations folks have a dashboard of all the pipelines, and they understand everything else that's going on in the environment. So they're able to take some measures and proactively avoid some of these problems that may hairball into a later issue. Which brings us to the connected, very, very connected point of monitoring. In a big data environment, in this modern data stack, reactive monitoring just won't work. It's already too late. The stakes are too high for you to go and understand after the fact that problems happen, that it happened. You want to be able to detect those problems early so that you can go and fix those problems. In that same pipeline example, what if you were told that your 2-hour pipeline is going to be late on minute 30? So that you could go inside, do something about it to make sure that it finishes in those 2 hours. Knowing after those 2 hours have lapsed, and then on hour number 3, you find out that your pipeline is running slow today, it's not a whole lot that you can do about it. Now, these modern data stacks are very dynamic environments. Even if you have just one app running and you don't have a lot of other users in the cluster, your application could become slow, your pipeline could be clogged because one of those stages are amiss, or you just have too much data to process today, or you don't have this kind of resources, your cluster didn't auto scale as it was supposed to. There can be n number of things that can reduce the reliability of this particular pipeline. So you want to work with your operations team to create some proactive alerts, to have some moments in time, maybe after each stage, to go and check how this stage has been performing compared to the last 100 times that this application ran. And if you start to see a deviation, then send me an alert so I can proactively start looking at it. Again, these are some of the things that in Unravel is baked inside the product already. And we take it a step further to do automatic fixes as well. Now, you want to create certain rules that if this problem happens, go and do this. For example, if you have a rogue user that comes out on Monday morning at 6 a.m., when I'm running my mission critical pipelines, I want you to kill that particular user's pipeline. Or I want you to email that particular user, letting them know that they're taking many resources and to go inside and make that pipeline efficient, for example. Because the only way to become proactive is to take an action on it as well. Just notifying about that problem may not take you that way. So this is something that you must all think about doing within your organization as well, is to work with your operations, is to work with your system admins, or whoever makes sure that the environment as a whole is running properly, to tell them to give you some proactive alerting and automatic fixes so that you don't have to go in and firefight these issues every time. And you have to monitor and measure everything. That's a very, very important part, especially if you guys remember that pipeline picture or remember your own pipeline picture. There are so many different components, so many different technologies that you have within your environment. It's not enough that you're only measuring one part. And it's not enough that you're only measuring one layer of the stack. You have to measure infrastructure all the way up to applications. And you should be monitoring and measuring everything, all of the different technologies that you have within your environment. Because things can go wrong anywhere. And if you don't measure and monitor everything, you will be blindsided. And when you're coming down to the root cause of the problems, you may not even know what actually went wrong in this particular case. Continuous optimization. What does this mean? Since we've got operating and monitoring, you may be thinking, hey, is this related? Is this different? Is this on top of? Like, what is continuous optimization? It's an extension of monitoring. It's an extension of operating, but it's done with the intention of hunting, finding, and implementing changes that'll help you improve performance, cost, quality, reliability of your pipelines and of the environment. If there are ways that you can implement some things that can uncover performance issues with each pipeline or application, you must instill that in your organization. There's a lot of, again, I come back to this environment and these data pipelines are dynamic. It's not about set it and forget it, because things keep changing all the time. You may have sized your containers as 128 gigs, for example, and that was done because it was December and it was holiday time and you were using it a lot. But now it comes in February and you're not even using 32 gigs of that. But your friends, the other data engineers, may be running out of resources, or your company may be incurring a large bill. So you want something that keeps detecting those kind of pieces so that you can constantly adjust and constantly tune and make sure that the cost and the performance of your pipeline and your entire cluster is taken care of. In this case, you can see a screenshot here that Unravel's constantly hunting for these kind of inefficiencies and even tells you what to go and change these values to get better results. You may also have changes that you can do not only to one app or one pipeline, but to the entire cluster, which will benefit a lot of different users and a lot of different applications in running their stuff faster, in making sure they're on time. And never forget that this is a data stack, right? At the end of the day, we're processing large amount of data. And another way to improve utilization, to lower your cost, one of the other hunts is to go and check how many of your data sets are actually being used and how many of your data sets are never used. So you should be able to do an analysis, which helps you understand how many tables do you have in your system, how many of these tables got accessed over the last 3 months, 6 months, 9 months, 12 months. And once you have these kind of markings on your data set, you can very quickly build up a dashboard like this that shows you, hey, I've got 14,000 tables out of 30,000, out of 40,000 tables that are actually cold, that haven't been used in a year. And then your data operations people can actually help you archive them or reduce those costs so that you can reduce 20 to 30% of your footprint in this particular case. And all that opened up data space means as data engineers and data scientists, we can bring in more data for our new model, for our new application, and keep running on them, right? So continuous optimization is that technique which constantly hunts for, provides you recommendations and fixes for, improving the entire health of all of those different stages that you have in your data operations. That's it, guys. I hope all of these different steps that we spoke about, again, we spoke about some very practical, precise things that you could be doing in your organization, in your different stages to get the right data ops practice. Always remember that it is a continuous loop, because from optimization, you go back to planning and you're onto your new app or you're onto your new environment, and then you're coding and testing and deploying again. For all of you machine learning folks and data scientists out here, you know that it's a very iterative process. And it's the same thing when you're looking at ETL or data analytics or just advanced analytics, applications as well, right? We will be sending you this deck. You can download it so you have this cheat sheet with you for how you should be selecting the right tech and planning for sizing your infrastructure correctly. And then the coding and testing phase, always remember, it's not only about your individual stages, but about the entire pipeline. You want to make sure that you work on these things end to end, and you check for correctness, you check for quality, but you also check for efficiency and performance of your entire data pipeline. And then once this is deployed, make sure that it's deployed with a good health score check so that you only have high quality stuff running in production, and working very closely with the people that are operating, managing this entire infrastructure and applications to make sure that you have some proactive mechanisms in there to detect this anomalous behavior, to be able to fix them in an automated fashion. And don't forget continuous optimization, because you will be running more tomorrow as you're running compared to today. And with this, you will be winning as a team, and you all be celebrating and hopefully dancing like the Chicago Bears did when they beat Detroit Lions. Thank you very much, guys. We'll take some questions and open this up for discussion now.
Fantastic. So a bunch of questions that have come through. Just a reminder for the audience, if you do have any questions, feel free to submit them in the questions box below the player. If you are watching on demand and would like to ask a question, feel free to email us at hello@unraveldata.com, and we'll be able to respond as we get them. So let's take a look at the first question. Which organizations are amongst the first to formalize the DataOps role? Is it the larger companies, or specific companies in certain industries?
It's a very good question, and we've had the fortune of working with a lot of different organizations that are running, data environments at scale. It's not easy to slice it up by the size of the company, but what we have seen is smaller groups versus larger groups have adopted DataOps practices faster. These smaller groups could be in a larger company. So if you have a product owner, somebody that has a mission critical need to get a data pipeline running, by a certain time of the month, then we start to see these different members of the team organize themselves in a way that helps you produce their results in a fast way. They may not be calling it data ops, but they start to follow a lot of these collaborative, agile practices that help them achieve their results within a certain amount of time. Because again, it's a very mission critical application for that particular company or that business unit within that company. And I think that's a great driver. So if you work with your product owners, and who are the product owners? These could be the business users that are defining the needs and the requirements of that data pipeline. And if you work backwards from when this pipeline is supposed to be in production, or when are we going to market with this pipeline, then you will start to see yourself develop ways in which you can shorten the time and increase the velocity in getting these pipelines to production faster. And that's where DataOps works best.
You talked a bit about kind of working with product owners and other individuals in your organization. Can you talk a bit about how Unravel is useful, or who Unravel is useful for? Is it just targeted at people who live and breathe data operations on a daily basis, or is it more broader than that?
Right. So, unlike the IT stack or your web stack that you had inside your organization, we see the data stack is used by every business unit inside the company. Marketing wants to use it because they want to understand their customers and want to create the best offers. Product wants to use it because they want to get feedback and iterate on their product. Finance wants to use it. Every department wants to use it. Unravel is designed for simplifying data operations. All those different steps that you saw in DataOps, from planning till operating and continuous improvement, it's been designed to go and fulfill all of those needs in a very simple way. It's out of the box information and dashboards, out of the box algorithms and automated insights that simplify things that you would otherwise be building. So it's really designed for that data team that we looked at today, the data engineers and data scientists and data analysts, to make sure that their applications are doing well. While they're coding, while they're testing, while they're verifying, that all those steps are taken care of within that one platform and they have a single dashboard to go to. But at the same time, we want to avoid the finger pointing, and we want to avoid people throwing problems over the wall and saying, hey, operations, hey, system admin, this is now your issue. So they too log into Unravel to go and understand not just individual applications, but how the environment is doing as a whole. So when problems do come to their table and they have to resolve something, like contention, for example, then they are able to understand the entire picture. They're able to understand what's happening with an individual pipeline, but also with the entire environment. So it's really a piece of software that we developed to make sure that all these different constituents of the DataOps team are able to get a single source of truth to come in one place and understand what's happening in the data environment with their viewpoint.
Let's change gears and look at and talk about how do we run ROI analysis to justify a data operations function. Where would you start? I guess this is probably being asked by a finance department.
Yes, especially now, every cost, every spend in the company is being questioned and re-questioned, and as it should be. Here are some ways in which you can make a case for data ops professionals inside your company. There are some cost cases that how would you be able to reduce costs, which finance, by the way, loves. And then there are some acceleration to your business cases, which finance may not understand, but your business guys may understand better. So let's run through them one by one. So on the reduce the cost side, you can make a case for how your infrastructure costs will go down because your code will be running in a more efficient manner. Somebody will be making sure that you're not overspending per application and for the entire cluster. So that's number one. And by the way, we've seen savings of starting from 20 to about 50 to 60% on just that use case. Then there is a lowering of your cost of support. We've always seen that supporting and fixing things reactively after it has hairballed into a problem usually takes a much longer exercise than looking at it in a proactive and in an automated fashion so that you can reduce the amount of tickets that you get and reduce the amount of time that you have to spend per ticket. So that's how you reduce the cost. And this total cost can be reduced about 20 to 30 to 40%, depending on individual organizations and their environments. But an even bigger benefit is how will you be accelerating your business? Number one, your business can now depend on the reliability of these data pipelines. Data products, data pipelines are new, and a lot of people are skeptical, so they may be just dipping their feet into it and saying, hey, let's see if this first experiment runs properly before we scale this out and start bringing in, more data products or data pipelines into our business critical stuff. And making sure that those things run properly can have huge impacts to your business. So guaranteeing reliability, making sure that things run on time every time is a big, big advantage to how your business can leverage data analytics. And the second biggest piece is just time to market. That entire data ops lifecycle that you saw, depending on what type of organization you are, if you're nimble and agile, you can release that in less than a month, depending on how complex your pipeline is. But for that same pipeline, without having that correct data ops people, skills, and culture, may take you 3 or 4 times the amount of time. If you're a bank and you got a fraud prevention app that you want to launch, you want to make sure that that finishes and it comes to market on time. Being even a month, 2 months, 3 months, 6 months late can have huge impact on how much revenue you could be generating or how much cost you could be saving from a business perspective as well. So the advantages of getting data ops are a lot, and we're happy to share some of these ROIs and case studies as well that may be useful for you to prepare a case for why you need data ops people and tooling within your organization as well.
That's great. We've got a very specific question, specifically from someone who's coming from the supply chain industry, retail supply chain industry. Could you tell us a bit about, some of the companies that you've encountered, or some of the use cases that you've come across with their use of DataOps to give them, a step ahead or competitive advantage? Can you talk to some of the stuff that you've seen in that industry?
Yeah. It's a very, very challenging and hot industry right now, right? All the orders are going online. The entire distribution is happening at breakneck speed. So there's a lot of data analytics that's happening. The companies fulfill their orders while staying competitive online. You can compare your prices very quickly online. Your local store is not able to sell that same thing that it was able to. That means your prices have to be up to date. You've got to understand your customer really well, so you can promote the right products and the offers to them, and make sure that your entire supply chain is able to execute that order end to end in a very timely fashion. Otherwise, you're going to be not getting repeat orders very easily. So we are partnered with a lot of retail chains, the largest one in the Midwest, some on the East Coast, where we are making sure that the data operations, those entire pipelines, are working on time every time. Now, there are very specific applications that I cannot go into because they are proprietary to those organizations. But to give you some flavor, they have sensor data that they get from all of the different trucks, all of the different warehouses, to go and understand not only the speed and velocity, but also the quality of delivery. A lot of these different pieces maybe need for refrigeration, for example, and they may have an expiry date. So making sure that those things are tracked in this time of a huge demand, and they don't are not without their needs and requirements of a refrigeration unit for very long, is something that they're tracking very closely these days. What we're also seeing is people are updating their prices literally every hour of the day now on a lot of the different common products that you may be seeing. Some of these prices of products are a factor of supply and demand. Clorox wipes, toilet paper, all of the other high needed demands are fluctuating in prices literally every day. And understanding what kind of margins you can make and doing price sensitivity is becoming a big data problem now, rather than looking at it on a spreadsheet. And lastly, customer loyalty and 360 is now top of mind for a lot of retailers. This is a time when people have created new bonds with their brands, especially in retail, because they were able to get things faster, because they were able to get the wide variety of things from that particular retailer. So there's a lot of analytics that these retailers are doing to go and understand what does a customer need, what else can we be presenting to this customer, what kind of offers can we give this particular customer so that they keep coming back to our store. And a good data ops practice has allowed these kind of companies to not only create all these different data science products rapidly, but to put them in production faster, because you couldn't wait for these things to get to market fast enough, right? So companies that have good data ops practices, again, one of the largest retailers in the Midwest have done this really, really well. They were able to implement this in April itself and have been reaping benefits and growing multiple folds, since the pandemic especially hit, because they were able to get that brand loyalty with the high speed in delivery, and making sure that these applications, ultimately run every day for them.
I think we're heading towards the hour now. I'd like to say that's all the time we have today for this webinar. Just a quick reminder that this webinar is available instantly on demand, so feel free to share it with your colleagues. If you felt your colleagues have missed out, feel free to share the link with them directly. If you are watching on demand and would like to ask a question, feel free to email us at hello@unraveldata.com. Definitely check out the attachments button below the player. We've got a link to the Eckerson DataOps deep dive report in there, but also a link to our free trial 14-day free trial, which is on our SaaS environment. Let us know what you think about the session by rating this webinar. If there's any other topics that you'd like to hear from, feel free to submit them into the comment section. On behalf of Unravel, thank you very much for listening. Thank you very much, Kunal. Any last parting words for the audiences that you'd like to say before we get cut off?
Thank you all for joining in. And DataOps, again, is a new practice, and we've got to keep these conversations alive. So we'd love to hear from you guys at hello@unraveldata.com. Thank you so much.
Thank you, everyone.